So I'm looking at the SEC 2018 Leaving Cert Higher Level Maths Paper 1 Question 2. It's a sequences and series question. The first three terms in a geometric series are x squared minus 5x minus 8 and x plus 8, where x is an element of the real numbers, so it's not a complex number. Use the common ratio to show that x cubed minus 17x squared plus 80x minus 64 is equal to 0. So I know what a common ratio in a geometric series, that OR is always equal to OR. And I can find OR by going T2 over T1, or I could find it by going T3 over T2. In fact, it's just a term divided by the previous term to get OR. Okay, so that's what I actually go and set out and do, because I know T1, T2, T3, and T4. So T2 there, T1 or T3, sorry, there, and T1 going in there. So now it's not really a sequences and series question, it's an algebra question. So I don't like the fractions, so I'm going to get rid of the fractions by multiplying both sides by x squared. Multiply this side by x squared, and the fraction will disappear on the left, but I still need to multiply this side by x squared, so it's as if there's an x squared going in here. And then I multiply both sides by the 5x minus 8 to get rid of this fraction. And if I multiplied the right hand side by 5x minus 8, the fraction would disappear, so I'm getting a 5x minus 8 here. So we found the x squared and the 5x minus 8 have cancelled. It's a matter of now multiplying out and being very careful. X squared by x is x cubed, x squared by 8 is 8x squared, 5x by 5x is 25x squared, 5x by minus 8 is minus 40x, 5x by minus 8 is minus 40x, minus 40x and minus 40x is minus 80x. Minus by minus is plus, 8 by 8 is 64. Tidy up, QED, done. Easy question, really nice. Okay, so the next question is a little bit longer. So if f of x is equal to x cubed minus 17x squared plus 80x minus 64, where x is an element of the real numbers, show that f of 1 is equal to 0. So they're really asking us to show that 1 is a root. Show that 1 is a root. If it is a root, it will satisfy the function. So I have to go and show it. So I'm subbing in 1 wherever there's an x. I'm multiplying it out, and I get 0 at the end. So therefore, x is equal to 1 is a root. I also know then that x minus 1 is a factor, and that the factors divide in evenly. Okay, so the second part of the question, find another value of x for which f of x is equal to 0. So another way of them saying this is find the other roots. Something that struck me is it's a cubic. There should be 3 roots. There should be 3 roots. Remember, a linear has 1 root, a quadratic has 2 roots, a cubic should have 3 roots, but there's no mention of plural. So either this is going to be a root twice, or the new roots that I'm going to find are going to double up and there'll be 2 of them. Okay. So how do I go and find them? Well, I know that x minus 1 is a factor, so I start dividing x minus 1 in. So I'm going to zoom in here for a second. So x by something is x cubed, that's x squared. And then I'm going x squared by x is x cubed. X squared by x is x cubed. X squared by minus 1 is minus x squared. I change the signs from plus to minus, minus to plus. Minus 17x squared plus x squared is minus 16x squared. X by what is minus 16x squared? It's minus 16x. That's why I'm getting this minus 16x up here. Minus 16x by x is minus 16x squared. Minus 16x by minus 1 is plus 16x. Change the signs from minus to plus and plus to minus. 80x minus 16x is 64x, and I've brought down the 80x from there, and the minus 64 now is being brought down. X by what is 64x, that's a plus 64 up here. Finish off the long division, fine. Now, this gets taken down here. I factorize it, I can use the guide number. The guide number is A by C, so it's 1 by 64, so it's just 64. I'm looking for the factors of 64 that add up to minus 16. So I'm getting, it's either 8 and 8, but 8 and 8 gives me plus 16. So let's try minus 8 and minus 8. that would be correct. And again, just in case you don't know how to use the guide number, I then go x squared minus 8x plus 64, and I factorize those first two terms now. So I'm getting, if this would move, x by x minus 8, and then x by what is minus 8, it's minus 8. And now as the two brackets are the same, I can bring it down to this line here. So I found that the two answers are the same. Both roots are the same. Both of them are x is equal to 8, which is fantastic because it kind of plays into find another. It's not plural. If the two answers here, if the two roots were going to be different, then they would mention it in the question. They would mention some reference to plurality, if that's a word. In the case of one of the values of x from part B, in terms from part B, the terms in part A will generate a geometric series with a finite sum to infinity. Important to note, if it's a geometric series and it's finite, the sum to infinity is finite, then the common ratio, the magnitude of the common ratio must be less than 1. So or must be between 1 and minus 1. Okay, that's important to note. So we now have two values of x. We know it's x is equal to 1 and x is equal to 4. So I've gone here and found this was our x squared, our 5x minus 8, and our x plus 8. And I've subbed in 1 for wherever there was the x's from the very start. And you can hear the dog whining. So I've gotten 1, minus 3, and 9. So if it is a geometric series, what if I multiply the first one by to get to the second one? It's minus 3, and then just check again. Minus 3 by minus 3 would be 9. So it does form a geometric series where or is equal to 3. But this one, I've tried it with x is equal to 4. So I can get, or sorry, not 4, 8. I don't know where that 4 is coming from. 8. 8 squared is 64. 5 by 8 minus 8 is 32. And again, they're all coming from here. I'm just filling in what x is. And I'm getting 16. And I'm finding that or is equal to a half. Again, t2 divided by t1. Or t3 divided by t2. Now, watch the question carefully again. It says it's a finite sum to infinity. And as I've highlighted here, this is quite important. If or is bigger than 1, the magnitude of or, so if the magnitude of or is bigger than 1, it is an infinite sum to infinity. Okay, so it would keep getting bigger and bigger and bigger and bigger and bigger. Whereas with the scenario like this, because I'm adding a smaller number each time, like I'm going to go 64, 32, 16, 8, 4, 2, 1, a half, a quarter, an eighth, a 16th, a 1/32, a 1/64, a 1/28, a 2/5, what's 2/256 is it? 1/256th. So you can see the numbers are getting smaller and smaller and smaller and smaller and smaller. So eventually we'll get to a point where we can't go any further. So our series that we're finding the sum of is the second one, because or the magnitude of or is less than 1. So our first term is 64, our common ratio is a half, and then you're using the sum to infinity of a geometric series. As a whole, this question, I think A and B are quite nice. I think it's a little bit tricky, that C part. Just that bit in yellow is going to catch people out. Quickly look at the marking scheme, sure, while we're here. 10 marks for the first one means it was probably pretty well answered. 10 marks for the second one, again, probably well answered. And 5 marks for the last one, obviously catching people out. Yeah, well, hopefully you found the video useful anyways.